In this video, I want to show you how you can do alternative method of calibration of the ultrasonic bolts. Some of our users want to collect information from load, ultrasound, and torque value at the same time. The previous method that I showed you, it was collecting data from ultrasonic and load. Then you would combine them together, come up with the average calibration curve. But in this video, I want to combine all of them together, which would come back with the ultrasonic torque angle data and load data. So some of these customers wanted to be able to go back and see how much torque they had while they were tightening and doing the calibration. So the setup is the same. In here, I'm going to activate all of these channels. This is the same setup that I had, but with activation of the load at the same time. So we'll be calibrating all and collecting data from all these channels: torque angle, load, and ultrasonic data. So let's get started with the software. So again, we have to enable the torque angle and load cell channels. Analog input, channel 1, which is torque, read the sensor, we transfer the information, calibrate, start cal. This should be around close to 0, and as you see here, this should be close to 0 also. In MC950 and US1, this value is close to 30,000, but in MC900, it is close to 2,000. So they have different resolutions. Okay, in case if you have difficulty, you can, if one of these sliders go to at one end, you can reset it just like this and recalibrate again and call start cal. It goes back and forth and calibrates again. This is another way of in case if there was no connection there or there was no cable and it goes all the way to one side, then you connect the cable, you come back, you have to reset it, then start cal. That's another way of doing it. Okay, and let's go. Make sure angle is enabled and go back. And channel 2, we can enable our channel 2, which is our load data. It's called tension here. And the label is tension. So let's read the data. So click again, read the data, transfer, calibrate, start cal. Same again, it shows you the close to 0 and close to 30,000 for load cell as well. So we enabled those two channels. File name, let's call this test. Let's call UCF, for instance. Channel 1, and the same parameters, recording, same again. I set it for 5 seconds of recording. Okay, here we set up our analog signals. Now we go set up our ultrasonic channel. So here we can select, let's say, up to 3 channels, maybe more. So bolt 1. In here we can set our average calibration to average calibration or nothing, because we'll be working with the raw ultrasonic signals and data that's coming from here, and we will not be using for this average calibration data. But if you want, you can use it. Let's see if I can find one here. 10. We can do that. This is what we started. This is only purpose is for calibration. So we go. All we need in this case: scan, echo, lock, 0 out, save echo. So come back here. Make sure this is enabled. So this is all enabled, ready to go. We have all the channels set up. So come back here, and we can set up our graph. It's real time. We can look at axis, x time, y1 is our channel torque 1, y2 is our, let's say y2 is our load, and y3 is our U1 tension. So we'll be collecting from all these three channels at the same time. So, scope it. Something I noticed, there is no channel here. We need to have ultrasonic signal enabled. Let's go back. Maybe I made a mistake. It's enabled. Channel 1. No, it's also okay. Come back. So we're ready to collect data. Arm it. So it's waiting for 10 Newton meter to start recording. Okay, we're done. So what I have here is our load data, torque, load, and our ultrasonic data all together. These two not necessarily correlate to each other at this point, but since we use the average calibration is using that, but what we're going to do, we're going to use the actual time delay data that resides in this channel. So that's what we have. So what do we do with this? At this point, we're looking at the real-time data because this box is yellow. We need to bring in the data and then separate these channels and save it to another file. So in order to do this, let's open the data file. This was the file that we just generated. Okay, it's the same file. Let me change this. It's group data. Sorry, it's a current file. Okay, it became red, and as I scan through this, and this information relates to this file. So let's go into post-processing. There's a tab here called AlterCal. AlterCal means it takes two channels, then it creates an average, a UCF file, ultrasonic calibration file. First one, you have to select your load channel, which is what we had was load 2. Then select your ultrasonic channel, which is U1 tension. And don't mind about this one. This is for dual sensor type calibration, which involves another sensor. We don't have that in this particular data collection. So click on make ultrasonic cal. So let's go in calibration. We call this test UCF. That's ultrasonic calibration file. It will become the same extension UCF file or anything else. Save. Okay. Let's cancel this. So what do we do here? We can go back, use setup. Remember, there was when we were trying to create the average calibration file, we were here. We went to create average calibration file. There are three options here. Either you can use the bolts that have been calibrated currently, which is in this from this window. We don't have any. Or you can bring an average calibration file. We already done something, already created this file. Or you can use that UCF file. You can do this. Open file. Let's go and test UCF. Bring this in there. We had only one bolt. So if I take this, if I select it, bring this here. That is our file that we generated from using our using our load cell and ultrasonic data. So that is what we generated. We can use this to create an average calibration file just like before, or we can combine with other ones. This is only one file. We can have more files and mix them up together. I can have, let's say, average calibration file. Let's bring it here, calibration. This is something we did before, we generated before. I can throw it in there, and here we have a bunch of more data together. And then we calibrate. If you want, you can eliminate any of them you want. For instance, if you don't want bolt 3, you can delete one. It goes out of this this average calibration group. One more thing I want to point to is common data. Common data means least amount of data that's common between all these bolts. At this point, if I uncheck this, you see the longitudinal data is -195 and 0 to 32 kilonewton. If I click on, so the common amount of data which is between all these three bolts is between 0 to 27 kilonewton, and the file, the time delay data is 0 to 82 nanoseconds. So that's what the function of this common data is. At this point, it's using polynomial. If you don't want to use polynomial, you can use interpolation. At interpolation, it just goes one point at a time and interpolates. And once it reaches the end, it stops and puts the same value. It will not increase. And same as on the other side. But if you use polynomial, it will continue on, and based on whatever value had before, it will try to predict the future values.